Okay. Okay. Hi guys, I'm back. So, this is a part 3. No? Hindi ko alam bakit nagloloko yung PowerPoint. Anyway, so this is skin effect. This is the conductor. No, pag higher frequency na pumapasok diyan, which is the UHF, no? UHF. This is from 300 megahertz to 3 giga. Alam natin, at 1 giga is where the microwave exists. Okay? So, yung current mo daw, yung frequency mo, ay hindi na sa loob dumadaloy. Hindi na sa loob. Siya ay dito na sa nasa surface ng skin at may ready to fly away. Yan is skin effect na tinatawag. Okay? So, yung tuned circuit is made of inductance and capacitance and resonate, no? Where XL is equal to XC, their inductances. Okay? XL is equal to XC. Okay? Then the term tuned circuits and resonate are used in, pwede mo daw pagpalitin, halos pareho naman talaga yan. Okay? So, tuned circuits is the frequency selective, no? So, ito yung pinaka mo, no? Kasi pwede kong humaba yan, no? Pwedeng, depende sa bandwidth. So, this is your low sideband. This is your upper sideband. Okay. So, frequency selective, no? Kaya nga depende, kaya nga nagkakatalo tayo sa selectivity, no? Pag, no? Dapat maganda yung bell curve. So there are two types. We have series and parallel resonance circuits. Okay, series resonance circuits are often referred to LCR or RLC. Okay, when inductive capacitive reactance are equal. Ito yung sinasabi kanina. Okay, and the formula for this is 1 over 2 pi square root of LC. Okay. You can solve for the resonance frequency. Ayan. So series resonance circuits, and they will meet at this point. No? Ito yung XC, ito yung XC, ito yung XL. Okay, ito yung XL. Tapos, their common intersection will be this. And that is your resonance frequency. Example, we have short circuits resonance series resonance we have given of 2.7 picofarad and 33 nanohenry. Using this formula, 1/2 pi the square root of LC, then we have 533 megahertz. Bandwidth. In other book, bandwidth is letter B only. Especially in Blake, no? If we're going to use the Blake book, the thickest one, the white book of Blake, the communication system, no? Ang title niyan is Communication System. So it's a part there in chapter 18, okay, that the bandwidth is just a B, especially in the power of of the antenna, okay, as well as the power. There is a temperature of the sky, okay. Lumalabas yung bandwidth na yan, which is letter B. Basta't ganun, may ibang book BW. Alright? So this 3 dB point is also what we call the 70.7 or the half power point. No? So ibig sabihin, ayan, no? Ito yung bell curve. So meron kang 3 dB point. Andito yung maximum mo. Andito yung maximum signal, maximum I would say, selection of your bandwidth. Ibig sabihin, in any station, meron kang lower sideband to upper sideband, you can choose no where it will be your station tuning. The same thing happen to your microwave, no? Because of this is your microwave parabolic antenna, you have a feed horn. Okay, this is your waveguide. So it will give you a frequency loops. Now the receiver can can stay here. If you have a receiver, you can stay here, here, or here as long that you are under the 3 dB point or the 70.7 loops. Okay? Pag dito mo nilagay ang antenna mo, you have a poor signal. Even here. O more here. Okay? Kaya nga yung mga parasitic element natin sa bahay, yung Yagi antenna mo, okay? Pag nandito ang iyong um, andito yung transmitter, okay? So mahirapan ka makachop ng signal. Okay? Kaya mas maganda, kaya iniikot yan eh, di ba? Niro-rotate yan. Okay? I-tune mo sa middle frequency. No? Pag nakuha mo na yung 7, kuha mo na lahat. So this is the different frequency response. No? If the Q or the inductor, the quality of the Q is and the selectivity is getting broader. Okay? If it is a low Q, no? Ito yung blue ang inyong frequency response. Okay? Ang laki ng selectivity mo from that point to that point. Okay? Yan, may mga kanya-kanya application yan. Okay? Depende yan sa Q. Okay, parallel naman. Okay? Ayan, ito yung colpits usually, no? Good example of this is the colpits, your experiment number 2. Okay? So, now this also a tune circuits in your receiver, or in your local oscillator, no? If you have a local oscillator, kasi if you have the antenna in your receiver, no? Now even in transmitter you have an oscillator there. Now you have your RF amplifier, no? This is your RF amplifier, siyempre. So meron kang mixer. Meron kang mixer. Tapos meron ka ditong local oscillator, LO. Magpo-produce lang siya ng sine wave. And usually they are made of colpits. Okay? Para paglabas mo dyan, meron kang intermediate frequency, tapos dadali mo sa amplifier, which is 455, no? 455 kilohertz. Okay? Tapos meron kang detector diode, and then you have your audio amplifier, and then you have your speaker. You have your speaker. You can hear now the audio frequency. The carrier will be now thrown into the ground, your carrier frequency. That this is for AM, no, AM band. What is happening to your receiver? All right. So usually the local oscillator will produce this one. Okay, siyempre ilalagay mo siya ng battery yan. May battery yan dito. Okay. Tapos pag nag-charge, magsusupply sa rito. Tapos magpo-produce ng isang direction and then okay, magdi-discharge another direction pag clockwise. Kaya nakapag-produce ka ng sine wave. Okay. So, a tune circuit a resonance in parallel appears to have finite resistance. Okay. It doesn't draw any current from the source. Okay. So, walang sinking. Have infinite impedance. Okay. Z. And act as an open circuits. Okay. However, there is a high circulating current between the inductor and capacitor, storing and transferring energy between them. Okay. So that is also, we call it sometimes, there are tank circuits. No. Okay. Now this time, so after tuning, we have now filtering. Now you will notice, if you tune to a certain uh, station. Okay, this is your 3 dB point, or your 7.707 or 0.707. Okay, yan, dalawang yan. So ang mangyayari, so ito yung lower sideband, ito yung upper sideband. So you can now reject the signal here and the signal there. So this is will be your band pass filter. Now, if you want to reject the lower sideband and allowing the upper sideband, so that is high pass filter. If you want to reject the higher sideband and allowing the lower sideband, and rejecting the lower sideband, or the upper sideband rather, that is low pass filter. Or you can have this one, no? If you want to, ay mali, ano pala to? If you want to, okay, merong isang filter na, yan, ganyan yung kanyang signal. Ay, kanyang, ano, you are rejecting, you are allowing the lower sideband, and you are allowing the upper sideband, and you're rejecting this, no, this certain station, and that is reject, band reject, no, band reject. Okay, yeah, see, so there are low pass filter, high pass filter. Okay, so we should know saan to na saan ginagamit, di ba? Especially the low pass filter, no, yung mga low frequency, di ba? So minsan, ano ba yung sa speaker, like we have your low your bass amplifier, di ba? Your bass speaker, okay? O your woofer kung tawagin. So may capacitor yan dito. Ang tanong, paano connection ng capacitor? It is for low pass or high pass. Okay, so we have to discover that. No? Then usually it is made of RC filters, no? Made of capacitor and resistor. Okay, and there are combinations, no? And capacitors to achieve the desired frequency. Okay. Okay. So at low pass filter, ayan. So ano yung kanyang, ayan, no? Naka-ground yung capacitor, no? Yung negative, naka-ground. So you're allowing a low frequency, and then rejecting the high frequency. Pag ganyan, no? Tapos no, ginamit mo yan sa isang application. No, you can Google that, no? I think you have to look for that application. High pass filter. Kasi dito sa wala namang binanggit dito, no? Kaya nga, so your assignment is look for the applications. Baliktad naman, no? Naka-ground yung resistor. Okay. You can use an RL, nga lang medyo RL, mahirap i-rewind ang inductor. Then nuts or reject o band stop kung tawagin o band reject, okay? You can use this kind of connection, a combination of high pass and low pass. Ito high pass yan eh. Ito low pass. Okay. Ayan. Yan yung band reject. Filter are used combination inductor to achieve desired frequency. Okay. It's either you parallel them or interchanges their positioning, the connectivity, and then you will have different designated purposes. Okay. There are filters for passband. Okay. Range over which the frequency, no? You just allow a certain band, no? Ito yung stop band, of course. There is a frequency outside the pass band. Then is the amount of loss, no? And attenuation. Now there's also in LC filter. Okay, in LC filter there is also an insertion loss. Okay, there's also an impedance. Is the resistive value of the load and the source termination of the filter. There is what we call a ripple effect in terms to describe the amplitude violation with frequency in the passband. Or there's a shape factor. Okay, so anyway, we will be discussing this effect of an LC. Kanina kasi RC or CR. Now this time in LC, these are the significance of using them. Okay. An LC filters also has its pole, no? Tinatawag natin pole is a frequency at which there is a high impedance in the circuits. Now, ganito guys kasi yung impedance eh, no? Ano ba gamit dito sa electronics, no? Pag impedance, okay? If you have a transistor, okay, this is a common emitter, okay? Okay. And then di mo siya basta-basta iko-konekta daw. Yung output mo, hindi mo basta-basta iko-konekta sa speaker. Kasi daw, ang output impedance ng transistor ay medyo mataas compared to the 8 ohms of your speaker. Di ba? Kaya minsan, in between them, nilalagyan siya ng common collector. Kasi yung common collector, ang output impedance ng common collector is low, very low. Now, it's ready to connect your speaker there. Kaya wala kang amplifier. If this is your amplifier, you cannot connect them directly. So we need an interfacing factor, no, interfacing technique rather, interfacing technique para mapakinggan mo no speaker. Okay? Sir, paano kung walang dinirekta mo, maingay yan. Okay? Gusto mo ba ng entertainment gadget na maingay? So, of course, hindi, di ba? So, yun ang gamit ng mga impedances. Now, in terms of LC, tumataas ang high impedance. Yan, ito naman example. Pag sinabing high impedance, hindi ka basta-basta papasukan ng mga noises. Kasi, no, susceptible, not really susceptible, yung, no, parang open circuit ka. Di ba? At low impedance, pwede kang pasukan ng noise kasi konektado ka eh. Pero at high impedance, seemingly, they are open. Kung open yan, di ka papasukan. Kung noise tong signal, noise yan, di pwedeng pumasok yan, di tatawid yan. No? Di yan tatawid. Kaya ito yung mga parameters o nangyayari at LC. Okay. Okay. Envelope delay or time delay is the time it takes for a specific point for an input waveform to pass through the filter. So, minsan din we have to delay signals, no? Lalo na pag ang signal mo ay uh, manoise. We have to reshape them. Kaya nga meron kang feedback, no, to reshape the waveform. Nga, habang nire-reshape mo siya, okay, siyempre nagkakaroon ng mga delay. At the same time, no, uh, nagiging nagiging maganda na yung output mo. Okay. Maraming purpose ang ano eh. Kaya nga sa RC meron tayong feedback, no. And there are situations that signal must be delayed, no. Lalo na pag ang signal mo ay merong interference, nahaluan ng interference o nahaluan ng noises. So, i-ano mo siya, i-reshape mo siya. Roll off of or attenuation rate is the rate of change of amplitude, no, with frequency in a filter. So ito yung mga roll on roll off natin katulad kanina kung tayo ay babalik sa mga response, frequency response like this. Yan, ito roll on to. Roll on yan. In switching, no? In switching ng frequency to frequency. From high to low to high. Excuse me. Now, filter also can be made of butterwork. Okay? Ano ito yung mga taong nagpursige para pagandahin ang ating mga filter circuits. Chebyshev, Cower, and Bessel Thompson. Okay. Ito yan. The best response is the butterwork. Okay? Is the butterwork. Kasi very smooth. The butterwork. Now, in any system, it is in any system when you turn on a certain circuits, a system, when you turn on a system, okay, hindi mo na yan hindi mo na mag-stable ang kanyang performance, Mag-oscillate muna yan until gumanda na yung performance niya. Okay? Okay. Now, there's a such thing of mechanical filters. And a mechanical filter uses resonance vibration of mechanical disc. These are yung crystal oscillator, kailangan mo kasi ng mechanical force o vibration. Anyway, tingnan natin yung susunod. But a bandpass filter configured with series or parallel resonance. Okay, sabi natin kanina yan. So, a combination of LCR or this one. No, that is a band pass. Okay, band reject. It is a narrow band or frequency around the center, or we call it notch. A band reject filter are also known as band stop. So these are wave traps. Okay, especially in television. Kasi dito sa mga application ng higher electronic like television, okay, band stop. Okay, nasaan tayo? Wala na. Kasi yung mga band stop na yan ay palibasa kasi in TV there are composite signal, no? And we have to take care of the right composite signal to be tuned. No? So there's such thing of crystal oscillator. Okay, ito yung lata, no? And they are made of ceramic, and you are using it as oscillator to set a higher frequency, okay, for a precise higher frequency. Okay, and they're also used for band pass filter. Now, this is a quartz signal. Ito, quartz yan. Ito yung symbol ng crystal oscillator. Ito ibang standard dito. Pero usually ganito ang crystal oscillator. Okay. This is a ceramic type, no? Filter. We're not you will see kung saan just Google kung anong mga application ng ceramic, different types of filter. Okay. There's a saw, we call it a surface acoustic wave. It's a special form of crystal filter designed to provide an exact selectivity. So mga higher transceiver, no, like modern TV, radar, no. Okay. And even your cell phone. Kaya magandang signal nyo sa cellphone. Bihira kayo mag-choppy because your filters are dedicated for that. Okay, ito yung acoustic wave filter. Okay. There's such thing of what we call switch capacitor filter, also known as analog sample data filter. Okay. They're made of op-amps, capacitor, and transistor switches. These are technology, making compact those different types of filters in one package. They provide a way to make tune or selectivity, no? Kaya nga meron tayong FM sa cellphone, no? Because they are made of switch capacitor filters. Are replaced by capacitor, no? Resistor are replaced by that are switched by MOSFET. That is the MOSFET technology, replacing the passive component. Okay. This is your IC integrator. Okay. Ito yun. Ito yun. Actually, ito yun, no? Conventional integrator, then we have the switch capacitor integrator. Okay. Naka-compact na yan. So you have this, no? Kung kaya may logic circuits, no? It serve as a counter. Okay. And then if you have an advanced math, you can study this to your advanced mathematics. All right. That's the end of our chapter 2. Okay, consists of oscillator, consists of shunt circuit of filters, no, consists of noise, and its mesh indicator, mga DBM indicators, no. So marami tayong na-tackle, different types of filters, different type of oscillator, no. Both these things is being used in transmitter as well as also in receiver. No, but we are very familiar with this. No? Nagkatalo lang sa mga current rating, wattage rating, voltage rating. Okay. All right. So this is your week. This is your week 3 lectures. And then I'll see you on the week 4 for your unit test 1. Have a nice night. God bless. Thank you for listening.